Being the celebrity, Donald Trump jointly acted with Lee Capido, and then Lee Capido acted with Amitabh Bachchan in The Great Gatsby, right? Where this we can get it? There is a website, the Oracle of Deccan. In this website, sir, is it possible to copy this link and just paste in a browser for users now? If possible, sir, if it is.
No, sir.
Okay, no problem. So in the later slides, I will show you these links and all. Once I
Okay.
complete this presentation, and I can come back with the things. Okay, how connected the world? We started with the 6, and then the Facebook they proved the 3 point something. So I just make it as a 4. And in LinkedIn they proved that the 3. It's nothing but in randomly what is the average path length between the two people. I want to talk to the some unknown person. I just find that where he is working, and then in the top is any of my friend is working or not. That the way I try to reduce my connection, right? So the social graph will be constructed, and the graph we can find a path between myself and the person whom I am searching, and I will give the shortest path. Next slide. Any slide you have any doubt, please stop me. You always can stop me, right? Is it a social network? There is a simple diagram in front of you. There are three persons and there are two things, books and then movies, as well as always movies will have so many fans, book will have a very less fans. So the book is having a fan of one, and then the movies two people liking it. So it's a simple social network or not. I hope you will accept that it is a social network, right? Next slide. Yeah. Usually, hope we are very comfortable with the DPMS, right? There is a DPMS, there are some informations, nodes, and then edges. Graph means it's nothing but nodes and then edges, right? The nodes having details, ID, label, and attribute. Edges is nothing but the source and target. Can we draw the graph for this? It is very easy. We can easily construct a graph, right? Next slide, we'll have the graph for this. You can see in the slide, the one part is the information, the other part is the graph. Are you able to notice that some nodes are bigger, some nodes are smaller? Why there is a size variation? Any reason for this? Why there is a color? Why there is a variation in the size? As per the proper graph theory definition, it is nothing but B comma E, but you can see some difference here. Number of links, nice, very nice answer. Why the colors? Other two factors. So, degree of association. Good, nice answers. Similarity. So what that similarity means? There is an attribute. You can see the attribute is either one or two. It may be considered for male or female. So the attribute one are colored in one color and attribute two are colored in other color, right? So the simple diagram itself giving all this information, right? So who is that? The size is bigger, node size is bigger. It means that person having a high influence. So that person connected with the multiple people. So you can easily see that who are all the highly influenced people, you can make it as a bigger size. And then smaller size means those people not have a much connection. So this vertical size is smaller. In that way, we are representing this diagram, right? So the simple diagram, we are trying to convey how much information we can. Previously, the graph is nothing but B comma E. We will see the slides in the forthcoming slides. Now that graph theory concepts evolved, and in the picturization itself, we can see that a lot of information easily we are able to picturize it. Next slide. Yeah, Google search engine. So hope every minute we are using it, right? At least 100 times we are hitting. At least the 10 search we are making every day. Minimum we are doing something. Whatever we get doubt, even now if we have a doubt, immediately I'll go with the Google search, right? So I just listed some story of the Google search engine and then the major innovation of that. You can see that the Google toolbar, Google Maps, Google Earth, Gmail opens to public in 2007. Then 13 years, you can see the growth of the Google. And you see that, I don't know how many of you know this knowledge graph. Anyone have an idea about knowledge graph? Or you don't know? Can you tell it in a chat box? Then I can think how much I can talk about this. Do you people have an idea about knowledge graph? In 2012, the Google search engine used. So the Google started to use the graph theory. The coin word a graph started to merge. It is a knowledge graph. So anyone of you can tell, I'm not going to give answer of this knowledge graph. Anyone of you can guess that by the name itself, are you able to come out from any point that what is knowledge graph? You can use your mics. Feel free to talk. I hope it is the discussion forum. I'm not going to teach. I'm just going to share my experience. Any idea about knowledge graph? By the name itself, you can come to some conclusions. The graph will have some knowledge itself. Or by this graph, we will get some knowledge. Hope you used to see the data mining. We will mine the data to get some information, right? Ultimately, we need a knowledge from a data. So the graph is going to help us some knowledge base. Okay, good. Can you go to the next slide? Yeah, it provides structure and detailed information, new format and storing the information. These are all some information about the knowledge graph. I just want to see that how the knowledge graph used by Google. Next slide. So while looking this, is it a knowledge graph? Are you able to get some knowledge from this? If you think about James, you know about his birth date and the place he visited and the place he lived and what he liked, who's the friend of James. All this information are stored, right? This is the format that today's data are transferred. Usually we used to have a DBMS. Now we are creating the knowledge graphs. By looking the graph itself, we will get a lot of information. Oh, every family we can create a knowledge graph, right? We know the close circle who are all to us, right? We can create it. So we can see that common identity and common places visited. And in our family itself, if you can draw a knowledge graph, it's a nice exercise. You can see that it will be very beautiful. I hope most of you use the Facebook. You just download your Facebook data itself, then see that you can see that plenty of things, hidden things in your Facebook. Who liked so much your profile past 5 years, past 10 years. The forthcoming slides, I'll show you how to analyze the Facebook data. Next. Yeah, this is the one. If you type a Tamil Nadu in the Google search engine, I don't know how many of you notice, it will list some pages as well as in the side left, your right side of that, you will get some other information also. Next, please. Yes, web results have not changed. The result not changed. As it is, you are getting the web results. But what we are getting add on? The information about. Next, please. This is what the new. It's talk about this Tamil Nadu map, general info, the points of interest. I hope it depends upon the user. That panel will get a different information, right? So it's not a static. When you just depends upon our history itself, it will decide and it will give some other information also. If I'm talking about if I'm searching something, and with my search history, it will give some relevant information. If you search something with your search history, it will give some information, right? The pages will be connected. So it's detect that artificially it will detect that okay, this page maybe this guy will like. Hope you everyone purchase something in the Facebook, Amazon or whatever that online platform. You can see that a lot of products will be suggestion. This purchase happened, then this purchase also happened. Like that usual data mining, right? If you buy the bread, you will buy the milk. That concept. The same thing. The artificial intelligence, the graph models are helping to predict that what is related with what in a multiple angle, not only in the one domain, it's in a multiple domain. Even I go for some research stuff to the overseas, I'm not only go for the research purpose. I like to visit some places. So automatically it will tell the next event. So the event may helpful for me to attend it. Right. I'll come to the basic definition of graph. Graph, in the context of graph theory, it is nothing but a collection of nodes and then edges. You can see that there are 5 nodes, and then how many edges in this? It's not a tough question. You can answer that how many edges in this diagram?
7.
Good. Thank you, ma'am. Thank you. So it's a very simple, right? This kind of simple diagram we can easily. Good. Thank you for your response. Next slide. Okay. Now we are just little moving. I have a graph. I need to convert to the matrix because the well-known concept in the max is matrix. With the matrix, we can do the plenty of things. Graph theory having a much type with the matrix, right? When there is a graph, we can convert it as a matrix. And if you're giving a matrix to me, I can create a graph here, right? Okay, that is a simple graph. All the vertices and all the edges, row-wise, column-wise mentioned. If there is a connection, then there is a 1. There is no connection, there is a 0. It is a simple construction from a graph to the matrix. Hope it is easy for you people. You can easily do it. It is not a tough one. And then the matrix is created, right? There is a two matrix. One is incidence matrix and then adjacency matrix. Next slide. So graph, again, it's undirected, directed, weighted, the classifications. As the first slide, we have seen only without the labels, simple lines and dots. And then the next slide, we just had a label of the graph vertices and edges. Now you can see that there is a direction or there is no direction and there is a weighted also. It depends upon your, if you consider your road networks, you can see that the weighted graphs. So the two places will be located, and what is the distance that you can mention. That weight is nothing but the distance between the two places. Like that, you can depends upon your application. You will construct your graphs. Then you can create your incidency matrix or adjacency matrix for your graph. It's simple, right? Hope you have been able to follow till now. Next slide. Yeah, I'll come to your talk title: artificial neural networks. Can you just read a title? ANN actually just a graphs. You can see the collection of graphs in front of you, some colorful images. It's nothing but a graph is converted into a multi-stage, and you are again getting a graph and you are getting some information, right? You are doing so many stages of filterings or so many stages of what to tell filter or modification or graph reconstruction. We as a graph theory people tell it as a reconstruction. From one stage to you do that multiple things and you will reconstruct something and you will come out with something else. So those things are happening. That is nothing but the neural networks. It is a fundamental, depends upon your iteration, that output may change. It depends upon your iteration condition, your output may change. A lot of methods are there. So graph is going to play a major role in the neural networks. Next slide. Yeah. So I have always doubt. Deep learning, machine learning, artificial intelligence. I think you can see that the coming year also the admissions, the students are eager to get admission in IA and ML, right? Artificial intelligence and machine learning. I still have a doubt. If someone of you can help me, please feel free to help me. As of my understanding, this is the layer of the things. Deep learning is a subset of machine learning. Machine learning is the subset of artificial intelligence. So the artificial intelligence is the superset. It is my understanding. So then what is the meaning of AI and ML? Because ML itself is a subset, then I don't know what is the meaning of that. Why there is a AI and ML? It's my view. So you can see the source where I got this image. So I just follow this. Maybe the statement is correct or something else. We have a different statement for same questions, right? So I just believe that this statement is correct. So what artificial intelligence under the subset is machine learning and deep learning with the subset of machine learning. This is the architecture I used to believe. Next slide. The simple thing, when I had experience with the Wuhan First University, I just worked with the doctors. Usually they will have a MRI data. Even we don't have a much idea about what the brain or what the network. So it's MRI data. So they will do some pre-processing and they will give some Excel file. In this picturization, you can't feel that Excel file, but it is nothing but Excel file. From the MRI scan, they will convert Excel file, and then Excel file will be converted as a functional network. That's what picturized in this. As a graph theory expert, I don't have much idea about the other stages, whatever they mentioned, like those stages. But as the functional network, as a graph theorist, I know once the Excel file is given to me, what to do with the data. So which node is behaving what? If this is the node or this is the parameter is high and this is the parameter, I just find some relations. As we discussed in the previous slides, we try to create some knowledge graphs. Data is given to you, you need to train it and you need to create a knowledge graph. As graph theorists, you don't need to understand much about that, but you just need to know what is the meaning of the name or something. They will give it in a short name format and you should have the proper naming conversion. What is this? ABC means what's the original name in the brain networks, like that. So the brain data will be taken and it will be stored in a multiple things, and finally it will be the Excel file. So the Excel is playing a major role, right? Most of our source is Excel. So the Excel is easily possible to create a graph, right? Next slide. Yes. Now we talk about graph data defines further classified into multiple things: graph queries, graph algorithm, graph visualization, multiple things. It's not a single domain. In graph theory itself, now because of this, so many technology, but I believe you can read in the internet also. Graph theory plays in all the recent technologies. It's having a lot of functionalities. I hope the DBMS replaced by uh, graph database. Neo4j is the one of the famous one, like that MongoDB. The plenty of things are coming out. In the forthcoming slides, you can see that what all the new technology or things are available related to graph theory in the recent world. So the graph algorithm, yeah, as a research perspective, I just want to highlight here, you can concentrate on anything. Some of you are interested in visualization, then you can think about the graph visualization. Some of you are good in mathematics and you want to write algorithm alone, then you can think about graph algorithms. Some of you are good in a SQL query, then try to think about the graph queries. Sure, I'm sure you'll get some different kind of output, then you'll get a new experience. The works will be publishable in the SCI Index journals. Sure, I'm sure, because whatever you try, it's going to give some new outputs. What is research? We are going to try in a new way and we are going to get it out. Whether it is success or failure, that is irrespective of that. But as most of you are researcher, I suggest there is a three different direction here: graph algorithms, graph visualization, graph queries. I can replace the graph as the data also. Data algorithms, data visualization, data queries. If you are computer science, you used to talk about data analytics, data visualization. Here it is graph visualization, right? Next slide. So this is the three-layer architecture. The graph tech follows the graph database, graph computing framework, and graph visualization tools, right? Next slide. So there is some, like what to tell, lot of small company logos are there. Anyone able to find any logos which is relevant to you, or like you have any idea about that logo, or at least you know that in front of you a collection of logos are there. Good. Anyone else? SQL database. Nice. Right. So we know only that our most of people we use SQL database, right? MS SQL or Oracle or IBM. Neo4j, AWS. Okay. Good. Good. So I hope some of you at least know some things, right? So it's very good. There are a lot of companies and organizations working towards the graph database. I hope soon the graph database replace the database management system. Next slide. So the next topic is graph processing frameworks or engines. Hadoop, the famous keyword, and graphics, and graph engine, power graph, lot of things. Why I'm just sharing these things to you? There is a lot of openings in this field. I'm seeing very less number of crowd in this. I'm seeing a very less number of publication in this field. So I just suggest this domain is going to be very nice domain if you want to work in this field. Publications and things going to be somehow better. I'm seeing the people are working on this cyber security and plenty of things. Lot of publication, but here the plenty of open problems are there, but the people are very less to work in this field. Next slide. Graph query language. You can see that AQL, graph, like plenty of things. You will just give a graph data and we'll get a lot of information, right? So we'll see that sample in the forthcoming slides. Next slide. Graph analytics toolkit, as someone mentioned, Neo4j, NetworkX, another famous one, and your Python, scale graph. So please try to explore iGraph. It's a very famous one. So just please try to explore this keyword. Surely you will see that lot of nice innovations. Next slide. So these are all some graph visualization tools. I'm just listing that each domain, the multiple technologies are there. I suggest there are multiple domains. So just find which one is comfortable for you and explore the things. That is the only purpose for these slides. Next slide. Right. We'll come to the one thing. What is this, sir? Okay, there are a lot of tools. How do I start it? Okay. Graph drawing. Like drawing, graph drawing is an art. I'm giving a collection of nodes and edges. So just drawing it in some decent manner or not in a decent manner, some structured manner, that is very great job, right? So let's see that some example that the way we draw, we can easily understand the data. So the graph drawing is a great area in a computer science as well as the graph theory. It's called as a information visualization. Next slide. Next button. Yes, there are simply four vertices. I think how many edges? Six edges. Next one. Yeah, you see that there are three different patterns here. So which one you like it? I mentioned it is the first one, second one, third one, and the down is the third one. Left, right, down. Which one you like it? Can you type L R? Then it's down. Okay. So others, left or right or down?
Sir, left, sir.
Left. Okay. So depends upon the application. Each one have its advantage as well as the disadvantage. Left one we have a crossing, right? When we consider about the wiring system, if you have a crossing, the one above one will trouble you. The connection will be the best issue. But the pattern, square pattern is always comfortable. When you design a hardware, you used to think about the square pattern, right? But second one, there is no crossing, but the boundary line is higher. The third one, you can see that the triangle, right? When I'm designing the component in a triangle pattern, this is okay. You see there is simply the four vertices and six edges. There is. I'm just illustrating a thing like that. You can draw it in a multiple way. So the drawing is the great art. Next slide. You can see here some nice architecture. You can see some colorings also. Can you guess why there is four zeros and four ones alone in a different color? You can see that some colors pattern here. And another one, from one place to other place, the distance is very nice. There is some stat difference in a single. Good, good. Sir. Thank you, sir. So there is what to tell. The distance between any 2 points. You can see some patterns here. Example: four zeros to four one. I can tell it as a distance is four. I don't need to calculate it. Take any two things. See the number of bit variation. That is the distance between the 2 points. Let us consider the triple one, zero, and four ones. There is a bit variation in the last bit. That's why the distance is one. Like that, if you take any two nodes, the label itself will tell you that what is the distance between the two nodes. You don't need to do anything. You don't need to look at all the edges. By seeing the labels itself, you can see that what is the distance between the two nodes. Right? It is the one of the property of this graph. Like that, it's a regular. You can see any node is connected with the four nodes. Right? It's a regular. Like that, the plenty of properties are there. Setting a one property leads us to publish some good works. Right. Next slide. You can see that other way of this same graph. Anyone know the graph name? It is a very famous graph. Usually people tell the name and tell the definition and they draw it. It's always, I prefer that giving a diagram than I'll ask a question. So anyone have idea about what is this graph? Hope you can get the answer from your chat box, hypercube. You have any idea about that? What is the hypercube? Yeah, thanks for the answer. Most of your interconnection networks, hypercube, cylinder, torus, hexagonal, these are all the famous networks. Hypercube is a very network, very good network for your network communications. I suggest everyone please explore what is hypercube network. Overall, working in wireless networks, mostly you people study the hexagonal network. I feel that very few of you only studying about hypercube. So I suggest think about this architecture also and think about this. I'm just putting another network also. So just these are all some famous networks for your network purpose. It will be useful. It's for your research purpose. Next slide. Okay, still now we explore something and we just come to the idea what is graph. Okay, now we are just going to see the simple graph visualization software, right? What is the simple software? With this, you can visualize some data. Structural information can be visualized. Next slide. Okay. Ma'am, can you go to the browser, ma'am? Is it possible for you?
Browsers.
No, browser, ma'am. Instead of PPT, can you go to the browser, Google Chrome or Firefox, anything?
1 second, sir.
Yeah, take your time. I suggest if anyone of you also using your mobile or something, you can graph this. Can you type graph this?
Graph.
Graph
Ah,
DI. I will type in the chat box.
okay, sir. Graph. In
You
that,
can
sir.
give I can give a URL. You can open
Ah,
the URL. And chat box the URL is there. So I think that the screen is visible. Everyone can see that. You can see that sample one. Ma'am, can you zoom it a little bit? Sorry for troubling you.
it's okay, sir. No problem.
Yeah, thank you, ma'am.
Okay.
So there is a simple code diagram G. Welcome to two to drill, and two to graph this. Then down you have a generate. I think in the down you can get the output now. Yeah,
Ah,
the graph is generated. It's a simple tool, right? This web link, you can generate the graph whatever you want. We started with a simple social network, right? We don't know how to draw it. Now this link you can generate a social network graph. There is a lot of examples, man. You just can click the examples, man. 1, 2, 3, 4. Sample examples.
can I generate, sir?
Yeah, yeah, you can. See, you can generate. So it's like a HTML coding. It's not going to be tough for you. So once you know the data, you're just going to feed it, feed it, feed it. A simple exercise. You can generate a graph for your department. What teacher, what subject they are teaching. Like that's something you can generate and you can paste it. It will be like look difference. It's not a tough job. Just how many faculty and what is the subject. Like that you can create some graphs. While looking the diagram itself, that will give some clear pictures. Right? I hope you people explore this later. So there are some simple examples. This is the way you can. Ma'am, slide, ma'am. How you can
Oh,
put. From current slide.
okay, sir.
Okay, thank you. So you can see that it is not a tough coding. You can see in your screen itself. There is a simple code, right? Graph example 1, 0, 1, 0, 2, G, 1, 3, 1, 4, 2, 4, 3, 4. So that nodes will be created and then the edges will be drawn. It is simple. It's not a complex coding, right? Next slide. Instead of numbers, you can give a text to label the nodes. Next slide. You can increase the thickness of the line and you want to give that, as we have seen some previous example for coloring and nodes or vertices uh, and the edges. It is very easy, not a big thing. As I mentioned, it is simple as like a HTML. Next slide. So you can change the size, either it is a square, whatever you want, you can make it out. Next slide. So this is the simple code with the colors filled by vertices and edges, everything. Next slide. Yeah, next slide. So yeah, usually I try to give some task anyway. So if you want, you can try this. I can give in a minute. So there is a simple code in front of you. If you do this, what is the graph going to come? Next slide. So answers is there. So this is the answer you will get. So if you want to practice more, this link will help you to explore further. So I suggest every one of you to explore this link to generate a graph. It's not only the graph theory, something you want to draw in your domain also. I hope this link is very much useful. Okay, next slide. Okay, so sir, 10 vertices, 15 vertices, quite okay. Even 100,000, it's fine. What is the real size of this? In the real world, what will be the graph size? So let us assume that social media. See that. What is this? 3.80 billion. Am I able to create the nodes? Am I able to do something? What you're talking? How I can do this? So how I'm going to manage this? As a beginner, those graphs are okay, but when you want to do in analytics, we need to develop something or we need to learn something which is already available, right? Next slide. So the next software is GIFI. Anyone have an idea about GIFI? Okay. Hope we'll get some information from this. You can see some statistics in your top of your slide, average number of nodes per group. So you can do the statistical analysis as well as the graph visualization. Please keep it in mind, this software have a dual purpose. One is graph visualization as well as the statistical analysis, right? As someone very clearly told, you can see that graph vertices size is different and the clustering is happening. All the things are happening here. The vertices are grouped based on some conditions. Here I think there is a 9 groups. So all this information are available. It is available as a API also, right? Next slide. How to do this? Very easy. The GFI, it's an open source. You can easily download. It's applicable. We can use it in Windows or Mac or Linux, whatever. Next slide. So once you installed, next slide now. This icon will be in your desktop and the visualization will, once you click this, you will get this one. Okay. So it's have a 3 things: overview, data laboratory, preview. Maybe if time permits in my laptop, I can show some examples. Here I'm just going to give some information about the software. So there are 3 things: overview, data laboratory, and preview, right? In the preview, you can see that how the output you want, whether if you want changes, you can do it. All right, next slide. So once you load in the data, the information will be look like this. You can see that it is just a lines and dots. You could not get any information from this. In this, you can see the left side something and then right side something, right? So the start is, as I told, visualization as well as statistics. There is 2 things. One is statistical analysis, another one is visualization. Both is possible in this tool. Next slide. So in this PPT, I just mentioned what is the purpose of the each tools and each plugins. Next slide. In the bottom, you can resize the vertices size, resize the edges size, everything that is possible, and you can do the statistical analysis. Yeah, next slide. You can see that you can preview your data. As I told very clearly, your input is going to be the Excel file. See, if you generate a graph, that graph can be converted as Excel, or if you have Excel, that Excel can be converted as a graph, vice versa. You know graph, right? Draw the graph. The graph will be converted as Excel and it can be used for some other DBs also or some other purpose also. Or if you have a data in Excel, you can easily generate a graph. But you should know what is vertices and what is edges. Any Excel, there is a property. The nodes properties will be in the nodes file. Edge properties will be in the edge file. So you have 2 files. One is for nodes, another one is for edge. So when you combine, you will get a graph. Next slide. So the data preview laboratory, you can see the data as an Excel file. Next slide. So I just listed a few properties and you can see that some statistical reports here in front of your screen. So we can calculate the average distance, lot of central closeness, centrality. I hope in the social networks we have a plenty of average path length and degree, highest degree, lowest degree, and average distance. Yeah, we can do the basic functionalities are there. If you find something is missing, you can do that and you can include this in the GPA also. It's open source. So I hope most of the things are useful. There is topological index, right? The plenty of topological index is there in the graph theory. Few of them are there. If you feel that something is missing, you can develop a plugin or you can do the version changes. If you give a code, I hope the open source, it may be in the next version, it will be considered and the things can be included. Another one, layout, right? The drawing layout. Next slide. So creating a new project, that is a quite easy one. Next slide now. Next slide. So you can, as random graph, dynamic graphs, multi-graphs, you can generate whatever you want, depends upon your requirement. Something you are working with the dynamic networks, you can create it. Next slide. Yeah, previous slide, please. Yeah, in this, once you create it, it will ask you number of nodes and number of edges, whether it should be the static network or dynamic network. Once you've given your inputs, you can, the graph will be generated. Next slide. So once you create it, it's look like this only. Then you need to do your all the filtration or reshaping. The graphs looks perfect. Next slide. So from the file also you can upload as we discussed. The Excel file. Yeah. After you do this, there are auto plugins are there. If you practice it, you will get it out. Next slide. Importing Excel. That is possible. Next slide. Next slide. Yeah. Here you need to take care of what is the vertices and what is the edges. That if you mention properly, the instructions are here. Sure, after the talk, I'm ready to share this presentation. So you can go through the presentation, how to import that Excel file. Next slide. So that after that, the data will be look like this. Next slide. Yeah, it's not only with that. There are a lot of plugins are there. So you can use the geo layout if you want to map with the geographical information. That layout is there like that. Plenty of there. The one famous exercise using a GIF is airport analysis. So that airport analysis project is very nice project. If you search in the YouTube, you will get it out. It is a very nice project. Next slide. Yeah. So till now we explored the two things, GraphViz and then GIFI. GraphViz for the beginners to draw the graphs in the online portal. GIFI is a tool which will help us to analyze the basic graphs. So whatever the data you have in your project, I suggest please explore this and try to import it and see then how the things are going on. Sure, the practice will come over, like give us some what to tell, some different view about your data itself. Right. Okay. Ma'am, can you, ma'am, that slide, ma'am, yeah, data visualization. Can you open the first link, ma'am?
Yes, sir.
How many of you know Jogo Analytics? Ma'am, I think the link is not working, ma'am. So anyone know about Jogo Analytics? At least anyone know about Sachin Tendulkar? Hope I should get yes now.
Yes, sir.
Yes, ma'am. Thank you, ma'am. So I think, ma'am, can you? Yeah, I'll copy paste the link in that chat box also. The others can see that. I'm just pasting the link in your chat box. So can you look at it and give your suggestions? What do you feel after looking this? In this, there is a data also. You can see that explore below the dashboard is there. Dashboard below, you can see that reports. Report below, you have a data also. You can do all the basic analysis. It's a simple GUI. You don't need to write a one-line code for this. All these graphs generated by the plugins. There is another one, famous one, Ask Dia. You can explore this. It's a nice thing. It will explore. Once you've loaded the data, you can see that it will generate some random questions and you can get some information from this. So it's a nice one. Next link. Ma'am, I'm pasting next link in the chat box, ma'am.
Okay, sir.
So in this link, you can see some sample projects by Jogo Analytics. I suggest everyone to start with this. It is, as of my experience, we have a lot of visual analytics tools. This is very simple to understand. Then further, you can learn Tableau or whatever you want. So I suggest if you're really interested in a data visualization, so quite one, all your AI, you can see that how smart it is telling. What is the sales of things? What is that? It's nice collection of some reports. Okay. So again, we are in a COVID situation. So I'm giving you another link which is relevant to analyze your COVID data. So that's third link. So the next project is Tableau. You can see that please, you people explore this, and if you have some suggestion, please share to me. I'm here to discuss. Even you feel that the links are not useful, you can mention. I'm ready to like take any of your input. Okay, so this is another project which is you can see that COVID analysis in the public folder. Even that this result is better than your media's news, so you can know better than that media's news, right? Okay, so ma'am, can you go to the slide now? Yeah. Next slide now. Yeah. Yeah. Till now we have seen the application of graph theory. Now I am coming to the core graph theory, graph algorithms. We discussed about graph drawing and graph visualization. Now the core graph theory. So I just plan to discuss this problem today to you all. Burning number, right? Burning number. It's having a good application. So you want to send some information, right? At the stage it will travel to the one distance only. So you need to pick a people with whom you share the information. That information reach the entire network how quick, right? If you want to convey the information, we used to target one student, and if we tell to the student that person is good to transfer the information to the all the classmates. Like that, we want to send some information in a network. Which nodes are active nodes? If I pass this information, that information will spread as quick as possible, right? I want to find that nodes. This burning number problem is a very famous in a social networks. Maybe it have application in your field also. So whatever the problem you are working in your research domain, if you are able to apply this burning number logic, and if you come out with the steps, sure that will be the new result, and it will be possible to publish in a top quality journals, right? What is this? Instead of going with the mathematical definition, I want to go with the simple example. Next slide now. There is a node, right? At the stage one, I'm randomly burning one node. So that node know the information. I want to tell some information, right? That node know the information at stage one. The stage one is over. What is stage two? That node will tell all the information to all other nodes. So at the step two, this network, all the information passed. That's it. The burning number of this graph is 2. Complete graph. When there is a complete graph, whatever the size, what is that? Complete graph means one node, every node is connected with every other node. So the burning number of kn is kn, complete graph, equal to 2. The kn, n can be anything. It is a lakh or whatever. It is 2. Next slide. So there are 9 vertices in a linear manner, right? So we are going to solve this problem. In this, you can see that I need to choose the vertices, and I need to burn all the vertices in the minimum number of steps. I need to cover this. So I have taken the V3, the step 1 is over, the V3 burned, right? Next step, what will happen? All the neighbors of V3 will be burned. Next one. And I am allowed to take one more vertices. Why I have not taken anything in the previous one? The 2 step is everything over, so I didn't take anything. Now what I'm telling, each step I can take a one vertex, and the next step all the burned vertices will burn the neighbor of the one vertices, right? Right. So the stage 1 I have taken a V3, so the neighbors are V2 and V4. It's burned in the step 2, and I'm just taking the vertices. I think it's V6. Am I right? So V3 is taken first, and then I think it's a V6 or V7. V7, I think. Right. Next, what will happen? Next, I'm choosing V8. All other nodes are neighbors of the previous born nodes, so it's covered. I'll go back again very carefully, slowly. Ma'am, can you just press the back button, ma'am? Empty graph. The first vertex is chosen. I'm planning to choose the V1, V2, I think it is V3. Step 1 is over, right? I need to choose the next vertex. I think I'll choose that V7, and all the neighbors of V3 is nothing but V2 and V4. It's born. And the next step, there are only 5 vertices remaining. So each one will burn 2 vertices, and then the last one I'm choosing. There are 9 vertices in the step 3 I'm completing. The burning number of this P9 is 3. So in general, next the bonding sequence is V3, V7, V9. So you need to find a sequence, and in a bit sequence, if you do, the steps will be minimum. You need to find out the minimum sequence, and then you need to bond it as quick as possible. So the minimum alone not a matter. The sequence also matter. If you choose something else, it goes in another way. If you suppose example choose the V1 as the first step, things are different. You can see that why I've chosen the V3 and V7 and V9. There is some logic. It's nothing but the total of 9 vertices. So each one will split it 2 at a time. So I'll just split as a 5 plus 3 plus 1. So whatever the thing, I will split as a 1 plus 3 plus 5, like that. I will divide it and then I will do it. Like that, I will choose. And then the burning process for this path is calculated. This theorem, like sum of n numbers, what is the formula? N into n plus 1 by 2. It is very basic formula till we are using it, right? Because of our usage, the formula is very famous. The same way the bonding number of Pn is square root of n. That is very popular. Why? Whatever the higher graph I'm going to solve, this result I'm going to take it as a first step. With this, I will try to conclude my higher graphs. Higher graph means I'm just talking about other graphs. Like example, what we discussed, the hypercube. The burning number of hypercube till today it is a open problem. If anyone of you able to solve the hypercube burning number problem, I'm sure it's going to be published in a top quality graph theory journals. Next slide. There is a simple grid graph. Is it possible to calculate the burning number? Let's try. Next, I'm randomly selected. The next step, what will happen? All the neighbors of this will be born. I can select one randomly. Next slide. Next slide. So I think here I have taken a step 4. So anyone of you able to solve this within the 3 steps? Try it. Or anyone of you able to do it in a 2 steps? Try it. Then you need to climb that. Okay, so minimum is 3 or 4 or 2 or 1, whatever. So 1 is not possible. 2 is also not possible. When it is 2, if it is complete graph or some other specific class of graph only, it is 2. So we know that it is more than 3, right? 3 or more than 3. So we need to prove that why it's not 3. Once you prove 3, it is not possible, then 4 is the answer, right? Okay, next slide. Yes, I want to discuss the open problems, which is very useful maybe to you people. So graph theory is applicable in artificial intelligence in an application perspective. But in a mathematics perspective, you have a lot of graph problems. You can look into this, and if you take a one problem, if you are able to solve the graph problem for a particular family of graph, that is alone enough. If you are solving, the burning number for the graph, it can be complete. Okay, you could not solve the burning number for the graph, then try to solve it for the specific graph. Example, hypercube or circular network or card graph. You take a small architecture and try to explore that. We have a collection of families of graphs. So each one has its lot of advantage, right? So the card graph, well-known architecture for the overlay networks. What is overlay network? All our physical networks map to the overlay network, and there is a mapping between the overlay network and your physical network. The one-to-one mapping need to be optimal. When it is optimal, you have a good topology mismatch between these two, then the network will be perfect, right? So most of our today's internet world, we are using the overlay network. The card protocol is the well-known protocol. So if you are solving the problem of burning number for a card graph, then it's sure there is a possibility of application of the burning number in a real-time networks, right? Either you can directly solve the application or give a solution for the application, or you can give a theoretical results. Those results later stage the people will use for the application. So there is a two direction. One is working with the application, another one is working with the fundamental graph algorithm. In the both direction you work, sure you will get it out some outputs. Next slide. Okay. So you have any questions till this time? exercise. I'm going to share my laptop to share that what the GIFI will do, how it is. So in the slide, you have any other doubts? If you don't have slides, any doubt, I think I can move on to my. Ma'am, can I share my screen, ma'am?
Sir, pardon, sir.
Can you stop? Can I share my screen, ma'am?
Okay, sir. Okay, sir. No problem. You can share, sir. Sir, wait, sir. I will first
Yeah, I
stop my
have some
share.
doubt in the questions, ma'am.
Okay,
Yeah,
sir.
one person asked one question. Any rule about how to select a burning node? There is no rule. We need to find a minimum number of steps. So obviously the first rule is we are not going to select the node which already born. Sure, we will select the node which are not born. So every step we will choose a node which is not born. And the logic is we need to choose the node which is far away. Yeah, there is no rule for that, but you need to intuitively think that what way I choose, then the step will be reduced. That's it. Only one condition per time you can take only one rule. Am I clear with your question now? Okay. So any other field you have any other doubt till now? I have explained something about the graph theory and the application of graph theory and some tools GIFI and graphs. Any basic doubts if you have? Or I can move to that. I can share my screen to show how the GIFI some sample projects. Can I move to the sample projects?
Participants, if you are having any doubt, you can ask our resource person. Sir, please check the chat box once again.
No, ma'am, I'm not getting any doubt. Yes, sir. This Kavita, ma'am, I don't know. I'm not able to get your question. Can I move to that sample project or what? List of all links. Yeah, that you can see, ma'am. In my PPT, you can see all the links. Like, if you have any doubt in your research direction, it is possible to applicable to graph theory or not. If you have any doubt, you can ask. Surely, I will explain something. Okay, I'll go with that sample projects. I'll share my screen, GIFI, what I'm doing. I think my screen is visible to everyone now. Is it visible?
Yes, sir. Your screen is visible.
Okay, now. So, just closing. I don't know. Okay, I'm just typing. I already installed GIFI in my laptop, so I'm just typing GIFI. So it's loading. You can see that how quick it is loading. So once you loaded, you can see the prompt box. New project, open graph file, Java, Power Grid, something. I just prefer Java. You can see that here you have the number of nodes and number of edges. It is not a dynamic graph. It is a directed graph. If you want to make it as undirected, you can make it as undirected. And you want to do with the existing workspace or new workspace, I just want to do it in a new workspace. In the down, you can see that the work is progressing. I'm just going to click OK. The moment I click OK, things are done. As I told, there are three things: overview, data laboratory, preview. Right. So here you can see that statistical analysis. You have a layouts. I'm just clicking this. There are a lot of layouts. I'm trying to click that label adjust. Trying to run. You can see that start working. The label adjust is working. Right. I'm just clicking the average degree. You can see that the average degree calculator. Data laboratory, previously that average degree value is not there. Now you can see that each node what is the degree calculator. Start from 1 and it's end with 755. The Java lang string having a 755 degree. among all, this one is having a lot of degree. 1 degree things also possible. See this. These are all the things are 1 degree. Right. You can see that only that you can see the nodes are here, edges also here. Edges, weights calculated, ID, label interval is empty now. Get the overview. So you can calculate the diameter. I'm just making this a one. So as I mentioned, thickness centrality is calculated, closeness centrality is calculated, harmonic, so lot of centrality. So these are all the things. You can see that which paper they used, what is the methodology they used, that also information available here. Right, and the page rank, graph density, and then average path length. So it's calculated, average clustering coefficient. So these are all the information. The graph size is higher, so it's taking time to load. And just close this workspace. Closing up. Import worksheet, spreadsheet. You can import your data, and then from them also you can generate the data. So I'm generating random graph, generating the graph, 13 nodes. Preview of that. Do this. Those are generated. So the wiring probability is less. That's why you can see that there is much less connection between the wires. So the data laboratory, you can see the ID of the nodes are there, 1, 2, 3, 4, labels are there. And then edges, you can see only there are 3 edges, 1 to 4, 1 to 7, and then 1 to 10. If you want to add the edge, 1 minute, ma'am. Ma'am, 1 minute, ma'am. I have one call. 1 minute, ma'am. Ma'am.
Okay, sir.
Hello. Ma'am, am I
Sir,
audible, ma'am?
yes, sir. You're
Sorry,
audible,
ma'am.
sir.
Just got on call, ma'am. That's why.
Okay, sir.
So you can see that what is the source node 1 to 1 and the target node suppose 1 to 5. So it is undirected, right? If I want to make it as a directed, I can. Like that, you can export the table also. Nodes also, you can export this table. So I'm just having a simple thing. If I load that, I think due to some system configuration, I could not generate the higher graphs. So you have a lot of statistical reports in this side, and you have this layouts options here. So it takes some time to The minus plus, you can see that. So these are all the sample projects which we discussed. Okay. So I just have just shown the sample defined works. So I think here I just want to stop my talk. So if you have any doubts further, I think we have a time, but still, if you have some time to discuss for the research or something, we can discuss.
Participants, if you are having any queries, you can unmute and ask your queries.
So what I planned, it's like interactive projects. If you are really interested, you can see the links what I posted in a group. If you see that, you can sure come out with some questions. I just want you to look into that immediately, and you can get the answers. That will be that.
Sir, a query has
Yeah,
been
ma'am, I
posted
got.
in chat.
Yeah,
Okay.
ma'am. What are the applications of graphs in blockchain? Ma'am, as of now, I don't have much idea about blockchain. I think, but the people are working with blockchain and graphs. I read some papers relevant to that. So I can share some papers which is relevant to that. Please explore this link, ma'am. That will be useful. Sure, ma'am. Sure, you can use that deep learning. As I have seen, like shared the PPT, right? AA is the subset, like ML is the subset of AA, and deep learning is the subset of machine learning, right? So graph theory is possible to apply in a deep learning. What is a deep learning? The way we think is matter, right? That sample data we need to convert it as a graph. Once you constructed a graph, plenty of tools. We have discussed this so many tools, right? You just apply something that will tell you some information from the constructed graph. So that is quite easy. Sure, you can do that. Application of burning nodes, yes, ma'am. It is very much useful in a social networks. So it's directly possible to apply in the social networks. And now recently we are trying to use this in the routing protocol. So these two places are majorly possible to apply the burning number problem. You can see that Anthony Bonotto, the Canada Ryerson University professor, introduced the problem. You can see his paper also. I can share his link now. You can see this. So this person introduced this problem. You can explore a lot about the burning number. Application of burning nodes, contact tracing in COVID-19. I think as of now, no one started this work, sir. If you try something, ma'am, it will be, sir or ma'am, it will be surely the new process. So, yeah, it's nice way. we need a proper data to proceed further. So if you have this idea about this, how to consider the data, then we can go ahead with this application. Yeah, I just instead of 1.5 hour, I just made it just now 1 hour. Okay, I apologize.
Okay, sir. Thank you, sir. You have given a very informative session to us. So the links that you have provided are very useful. So thank you, Patiban sir.
Thank you, ma'am. Thank you. I think that the very less time I concluded my talk.
So I think the
Anyway,
query session may be exceed for half an hour, but today the queries are uh,
yeah,
asked
that's what I.
manager.
Yeah. Okay. Anyway,
Okay,
thank you.
sir.
If any feedback, please feel free to share to me. Sure, I will improve myself. Thank you.
Okay, thank you, sir. So participants, kindly post your attendance. The link has been given in the chat box. So kindly post your attendance. So thank you. We can meet again tomorrow. Okay, thank you.
Thank you for the opportunity. Thank you for
Thank you,
everyone
sir.
listening past 1 hour. Thank you so much.
Attendance link has been posted in chat box. Participants attendance link is already posted in chat box. Kindly scroll your chat box above so that you can view the link.